Okay, this video is about using normal distribution to find probabilities. This is mostly a recap on what you did last year, and so we're going to move reasonably quickly. I'm also expecting people to have access to a Casio FX 9700 G2 calculator, a 9750 G2 calculator. So as we're going to run through that, part of the instructions I'm going to do is how using that particular calculator. All right. Here's the equation for the probability density function for a normal distribution. Which means that if we want to, we can just bang the numbers into that formula and use that to find the height of the curve, and then use that to find the area underneath the curve. However, the problem with that is it's completely unworkable and quite complicated and not something that we ever really need to worry about. So what we can do is we can use the calculator to work out our normal distribution. And in the calculator, if the steps that we go through are, we first of all go to the stats mode. Once we've gone there, we're going to go to distribution. Which is F5. Then we're going to click on normal. And that was F1, followed by NCD, which is F2. Once we're in that mode, we want to set it up to be in variable mode, not in list mode. All right, so make sure that you've set up as in variable mode. Then it's got four options that we put in: lower, upper, standard deviation, and mean. Right, for the standard deviation, it's going to use this symbol here. And for the mean, it uses this symbol here. Okay, so what that's saying is that if we wanted to find what the probability with the variable within a particular range, we can put the lower at the lower end of that range, the upper at the upper end of that range, and then just put in the standard deviation and the mean to find our answer. Let's have a look at a couple of examples. Okay, a normally distributed random variable x has a mean of 10 and a standard deviation of 2. So we're going to try and find the probability that x is between 7 and 9. So what we're going to do is we're going to look in here, what are our values that we want? So we want our lower. Well, it's between 7 and 9, so that means our lower is going to be 9. Our upper is 9. Our standard deviation is 2. And our mean is 10. And so we basically put that into the calculator. And we come out with the probability that x is between 7 and x and 9 equals 0.2417. Okay, looking at that same random variable, if we were to look at the probability that x is greater than 14, this is the only thing that's really a little bit different. So we have to think here. So we want to find the probability x is greater than 14, so our lower is easy as 14. But our upper, well, we can't do positive infinity. So instead we have to just pick a really, really big number. And once we get a certain distance away from the standard deviation from the mean, it is very, very close to 0. So here I would do 9.9 exp 99. So that gives us 9.9 and then 98 zeros. That's normally going to be enough for us to be able to get the right answer. So we have 14, 9.9 exp 99. And we get our answer. Probability that x is greater than 14 equals 0.02275. 0.02275. Right, let's have a look at one in a little bit more context. Okay, so here's a real life situation. The number of kilometres that my car gets per tank of petrol is normally distributed with a mean of 535 kilometres and a standard deviation of 28. What's the probability that I get less than 500 kilometres to a tank? Well, so again, I've got to think about what my lower and my upper and my standard deviation and my mean are. So here I'm saying less than 500 kilometres. So I'm going to have my lower will be negative 9.9 exp99. Now, realistically, I could just put 0 in because it's so far away from the mean that it's going to be the same, give me the same answer to at least about 16 or 17 decimal places. But I'll stay with this. Upper here is 500. So I'll put that in the calculator. And I get a probability that x is less than 500 of 0.1056. If I look at this next problem, what's the probability that I get more than 550 kilometers to a tank? Well, I'll do the same thing again, except this time it's more than, so it's going to be 550 is my lower. .9 exp99 is my upper. .99, and I get the probability that x is greater than 550 equals 0.2961. Okay, so here's the problem for you for this week. This is your homework. A punnet of chips has a mean weight of 125 grams with a standard deviation of 15 grams. The chip seller gives people their money back if their punnet has less than 100 grams in it. What percentage of people would get their money back? So you need to work out the probability of that and then answer that as a percentage.